Okay, I hope you might have understood what is the oxygen sag analysis through the video what I sent to you. Okay. Yes, who is talking? Who is talking, please? Let me know who is talking. Yeah, Prasad Dhekle.
Yeah.
Do you want? Yeah. Do you want to talk, Prasad? No problem, Prasad.
No, madam.
Okay. I thought you are asking something, so I was insisting. My strength is so less today. Okay, shall we start the point now? Till the last lecture, we have studied about the various points in the disposal of wastewater. As I told you, the disposal of wastewater divided into two parts. The first part is the disposal of wastewater stream pollution. It's a self-purification DO-SAG curve, Streeter-Fels equation for the DO-SAG curve. So this part you might have watched through the video now. Once again, I'm going to explain here, but I thought that you will understand little more if it happens a repetition. That's why I made you to people to listen that. Okay. So the second part, emerging technology, yet we have not started that. So in that first, we have studied about the methods of disposal of wastewater, and these are classified into three types, that is natural method, artificial method, and combined method. So there are two main objectives for the treatment of wastewater. Okay, so first one is to reduce the public health hazards, and another one is to reduce the uh, deterioration rate of wastewater, uh, which is getting affected due to the addition of wastewater from the various city or the industry in the stream. Okay, so I told you a cycle of use of water. Okay, how we are using the water, that cycle I have explained. So I will explain once again. I will try if it is not being listened by someone else. I will explain it once again. So cycle, how this cycle works, I told you. So this is one of the water source. Okay, water source. Whenever I am saying water, it is, we are talking about the drinking water, is it? So this is one of the water source. It may be a well, or it may be a stream. We will consider this is a stream. Okay, from the stream we can pump the water, or we can make available to provide the water to the treatment work with by gravity or by pumping, no issue. Okay, so this is the treatment work. In a treatment work, what is included? A treatment of water by providing various sequences. First, sedimentation, coagulation, flocculation, then coagulation, flocculation, mixing, then filtration, rapid sand filter, or slow sand filter. Then we can go for the chlorination. After chlorination, the water, treated water, will go for the distribution to the society through the distribution network. You might have studied the various types of distribution network. In that, dead end system, then radial system, then circular system, gridiron system. These various types of systems you might have studied, for which are used for the distribution of water. Okay, now here, at, as we are distributing this water, but the end consumer point is the end point. Okay, so from every consumer, there is going to be produce a waste water, as they have used water for drinking purpose and for the domestic activity. In the domestic activity, there will be the drinking, cooking, washing, floor cleaning, car cleaning, etc. will come. Okay, so they will generate the liquid waste from their individual. Okay, now it's a time to collect that wastewater, entire wastewater from the various end users, and that collected wastewater we are going to treat in a wastewater treatment plant. Here I am talking about wastewater treatment plant. Is it? This is not the water. This is the water treatment plant, and this is the wastewater treatment plant. Now here you are treating the water up to the extreme level. Extreme level, why I am saying extreme level? It will treat and will be a means you are providing primary and secondary treatment only. You are not providing tertiary treatment in a wastewater treatment plant. Why we are not providing tertiary treatment plant? It is too costly and it will not be affordable to treat that much huge quantity of sewage. Okay, so that's why we are not allowed, we are not treating that wastewater by using the tertiary treatment process. Then what we are doing, we are collecting that treated sewage, and we are allowing to dispose it by the three different methods whatever we have discussed at the start of this chapter. And these three methods are nothing but the natural method, artificial method, and combined method. Okay, so these are the three methods. Now we are focusing towards the this one, that is the natural method. This is one of the effective method to get water regenerated. Regenerated in the sense, again त्याला परत एकदा आपण आपल्या वापरात आणायचं, that is nothing but the regeneration. Okay, this is the one of the most effective way to go for to bring that wastewater into our use, or we can say regeneration. Okay, so this natural, again we can go by two way. One is the dilution method, and another one is disposal on land. Okay, if you are disposing it on the land, then it will percolate to the ground, and while percolation to the ground, it will act that soil, different layers of the soil will act as a filter, and naturally the water will get treated and it will be collected at the depth of earth, and that is what we can say, it is a groundwater. It will meet to the groundwater table, and it will mix into the groundwater source. So this source again you can extract with the help of well or bore well, and that you can use as a source to the water supply engineering. Okay, this is about when you are disposing the sewage or the treated effluent by natural method on the land. Okay, now we'll see another way. Another way is by another way, that is what, the disposal on by disposal into a nearby stream, pond, river, etc. And that method is known as the dilution method. So whatever we are studying currently in this chapter, this is about the dilution method. We are distributing that quantity of treated sewage into a nearby water body, and then it will mix into the good quality or the naturally treated water in the river, and along with that water, this new water, that is wastewater, will also be getting treated. That is known as the dilution method. And what should be the dilution factor that we have discussed in the last lecture? Is it? Are you getting? So again and again, I am trying to tell you that whatever the wastewaters treated effluent is generating, we cannot use this treated effluent directly as the source of raw water as a water supply. We cannot go for this, is wrong. Is it? Because it will quite difficult to treat that water. So we are taking help of nature and allowing to get treated by natural way, and then that source you can use as a raw water for the water supply engineering. Is it? Hope you understood this point. Then I will go for the next point. Okay, so this is nothing but the self purification, and that part we have discussed in the last lecture. After that, we have discussed factors affecting on the self purification. There are the various factors. What is the dilution, current, how the river or the stream which we have selected to for the dilution purpose, how fast it is running or how slow it is running. Is it? Then the temperature again means we can say local climatic condition matters upon the intensity of treatment. Is it? Sunlight and then rate of oxidation. This part we have covered in the last lecture. Is it? So the next point, actually you should write at least this part, factors affecting on self purification. Don't mind, but I will share this PDF PPT with you. But just for our connections, you please note down only the points. Factors affecting self-verification. Write down first one dilution, second one current. That way, at least key points you note down. Then we'll go for the next point. Write down. Is my voice audible properly? Okay. Have you written factors affecting on self-purification? Following factors are affecting on the process of self-purification. In that, first one is the dilution, second one is the current, then third one temperature, fourth one sunlight, and fifth one rate of oxidation. Along with these, few more are the factors, but I have chosen here for the presentation only the important and randomly which are governing the rate of self purification. Such kinds of I have selected over here. Okay, this part we have finished. Yes. Okay, we'll go to the next point, that is zones of pollution in the stream. Okay, now you saw the video and in that I have I tried to show to you how the water, when you are adding some quantity of water, sewage into a stream, how it is getting mixed into the stream and then how the it is getting treated naturally. Okay, that you saw recently in the video. Okay, so what kinds of zones are classifying when you are depositing a sewage at a particular spot into the stream? Okay, that you are going to see now. Okay, see here. There are the self-purification process of stream polluted by the wastewater or effluent discharged into it. It can be divided into the following 4 zones. What are the 4 zones? Zone of degradation, zone of active decomposition, zone of recovery, and clear water zone. Okay, so I will explain that part with the help of figure. Okay, will you please draw this figure first? Please draw it, then I will explain. I will give you a 5 minutes to draw the figure. Hope you everybody will finish it. Okay, I forgot to write. If you have written this one, first write down this. Zones of pollution in the stream. These are the 4 zones. Write it down now first. Zone of degradation first, zone of active decomposition second, zone of recovery third, and clear water zone fourth. Okay, hope you have finished. I will go to the next slide. May I? Okay, I will go to the next slide. So this is the zone of pollution figure. You can watch, you can draw, and then I will explain. Okay, so only one mistake I done in this figure, and that is nothing but I forgot to write the numbers. This is the first zone. So you don't write first zone, you can directly write the names of zones from the above list. That's why I made you people to write the first slide first, and then second slide after that. Okay, draw this figure. I will give you a 5 minutes. तुम्हाला झालं नाही का? का बरं? याच्या अगोदरचे होत होते त्यावेळेस. तिकडं मग आता पैसे काढेल. Have you done, guys? If yes, please reply. Bhosle Vaishnavi replied that yes, ma'am. Thank you, Vaishnavi. What is the other's opinion? I will wait for one more, otherwise I will start. Okay. So many of you people have replied that Divya, Priyanka, Sheetal have completed. So we'll start now. Okay. So zones of pollution. So what we are talking about, zones of pollution in the sense, one spot where you are disposing a sewage. One second. Just a minute, please. Something went wrong here. What happened? Okay. Zones of pollution. When this is a stream, you can consider this is a stream, and this is a spot where you are going to add a sewage. Pranav, Sneha Chormule, mute yourself. When I'm asking you people to talk, you don't talk. And then when Okay, this is the spot where you are disposing a sewage. Okay, now when it is disposed from this spot, I will take another color, from this spot to this spot. Suppose this much area has been consumed by the wastewater to get self-purified. Okay, so this portion, during that portion, this four activities will perform. These four activities will perform during this portion, and then you will be able to find, then at this spot, the stream will come to the main stage where at what point the wastewater was added into that particular river. Okay, so this part, during this portion, how this water is getting self-purified, that is nothing but these four zones activities are being performed in the river, and the water is getting treated. Okay, so let us see what are these four activities and how this water is getting treated. So we'll see once again to this figure. These are the particulars. So this portion I have written here, dissolved oxygen sag curve, then physical indices. What kind of physical appearance of that particular river you will be able to observe. And this entire area is a zone of pollution. Okay, this is where the spot where you are going to add the sewage. Is it? This is the spot, but immediately it will not be affecting on the quality of that existing river. That saturation level, it is written here, saturation level. What is meant by saturation level? The water or the river which we have selected for the disposal of sewage may be or may not be a saturated one. Is it? If it is saturated one, we can say there is 100% oxygen available. Okay, so there is no reduction of oxygen. Then oxygen, when you are deposited up to some time, that microorganisms will take time to get adjust with the new environment, and then they will start the degradation process. So the moment they will start the degradation process, from that we can count the different zones. So the first zone is nothing but the zone of degradation. I asked you to write the name to these zones. The first one is the zone of degradation. What happens in a zone of degradation? In a zone of degradation, so this is the first step. This is the first step where the degradation of wastewater starts. And initially, it will not fall down the entire oxygen immediately. In this zone, the process of recovery actually, what happens actually, the dissolved oxygen level will fall down up to the 40% of the saturation value. Whatever may be the saturation value of that particular stream, the dissolved oxygen level will fall down up to the 40%. It is because it is just after the just below the outfall of the sewer. Outfall of the sewer means wherever we have added the sewage. Next to that, there will be the degradation zone of degradation. And in this zone, what happens? Basically, this zone will be the dark and turbid in color. The formation of sludge deposits at the bottom, and then DO starts reducing up to the 40% of the saturation level. And as there is the degradation process starts, there will be the emission of carbon dioxide level. During, you know that whenever there is the, because this is the aerobic activity, it is not the anaerobic activity. So during the aerobic activity, decomposition during the aerobic decomposition, carbon dioxide starts emitting, and slowly the oxygen level starts degrading. And if the level of oxygen degrading or reducing, to that we can say it is the deoxygenation process. Okay, so these are the unfavorable conditions for the aquatic life, like the bacteria is present, fungi present, aquatic plants present, some of the breeds are present, worms are present, then aquatic animals are also present. So all of them, this environment is unfavorable. but still some of the worms will keep on working with the available quantity of oxygen and will start decomposing the solid matters present into that sewage, and then this takes place, the conversion into this prevents the anaerobic environment, anaerobic decomposition in the particular stream. This activity of worms will prevent the anaerobic condition, prevailing the anaerobic condition in this zone. Means only the aerobic condition will be observed here, because the dissolved oxygen level is also not dropping down 100%. It is up to the 40%. Okay. Then next zone comes the zone of active decomposition. This zone we can say it is an active decomposition. So physical indices says that it will be a grayish in appearance, darker in a color, CH4, H2S, CO2, M2 gases evolution. Okay, black scum at the top means a highly polluted area, we can say. This one is the highly polluted area where the microorganisms became more and more active. या portion मध्ये फक्त 40% का डाऊन होतं, तर ज्या मायक्रोऑर्गॅनिझम नवीन सीवेज मधून एंटर झालेले आहेत त्या 100% ऍक्टिव्ह झालेले नसतात अजून. So they need time, or some of them are active and they are consuming the oxygen. But as time passes, it is with respect to time. You can say it is with respect to time as well as it is with respect to length of the river. Is it? So that during this portion, entire microorganisms are not active, and hence the dissolved oxygen level is not getting down 100% in this zone. But as time passes and length passes, the dissolved oxygen starts depleting very fastly and it will reach to the zero level. And that zero level, we can identify a critical point. This is the zero level is nothing but the critical point in a sewage. Okay, so that's why it is, we can say it is an active decomposition. Actively 100% microorganisms are decomposing and reducing the BOD of a new sewage and trying to take water to the normal level. Is it? So that's why here a critical point will be observed, and then because it is a critical point, no oxygen, definitely there will be this environment is not favorable for the aquatic plants and aquatic or any kind of aquatic life. But slowly this activity, though it is going to be reduce the oxygen, so many natural activities of self-purifications are also working simultaneously on simultaneous front. So that's why they will help to increase the level of oxygen in the stream itself. So that's why at the end of this zone, you will be able to see again the level of dissolved oxygen is raising up. Is it? Again, it is coming to the 40%. And from that point to the another zone will start, and that zone is known as the zone of recovery. Okay, it will be the exactly replica of zone of decomposition. It will be zone of degradation. It will be exactly replica of the zone of degradation. This zone is identified as a zone of recovery, where the recovery of water is being performed due to the self-purification activity of that own stream. And hence, the physical indices in this zone will be observed as turbid with bottom sludge. So during this portion, when decomposition starts, that during decomposition, the sludge forms, and formed sludge will settle down at the bottom and clear water will be observed at the surface. At the same time, the level of dissolved oxygen will be increased. It will be more than 40% and will bring it to the 100%, towards the 100%. This is the first thing. At the same time, it is reducing the level of BOD present into the sewage. Whatever the BOD has entered along with the sewage, that can be removed, that can be start removing at this zone, and that's why this zone can be identified as a zone of recovery. And the last one is the clear water zone, where the original state of river will come to the original state, whatever before the outfall. Is it? This is the outfall portion. This is the outfall spot where the sewage we have added and the life of river has been changed like this. Okay, so before that point, the life of river was different. And that spot once again will be achieved after in this point, at this point, and from that point we can say zone of clear water. Okay, so one cannot say that here is the danger for the aquatic plants or the aquatic animals, because the dissolved oxygen level again rised up to the saturation level of the dissolved oxygen. Is it? So this way, this phenomena works when you are disposing a sewage into a nearby water body for the natural purification process or self-purification process. Okay, understood? Is there any problem? Do you want to ask any point here? Do you want to ask? Otherwise, we are running out of the time. We may need to get a reconnect once again. Just a minute.